An insert is usually made of not just one material, but is a combination of different materials. So the word grade is used instead of the word material. The cutting edge geometry and the grade of an insert are equally important when selecting an insert. The correct selection of cutting tools and cutting parameters, which is cutting speed, feed rate, and depth of cut, is the key to achieving high productivity in CNC machining. Which cutting edge would you use to cut a tomato? The axe or the kitchen knife? This picture shows the cross sections of an axe and a knife. The axe has a broad, strong cutting edge that can withstand high cutting forces, and the knife has a narrow, weak cutting edge that cannot take high cutting forces. Neither cutting edge is better. Each has a different use, and if you select the wrong cutting edge for an application, this is what happens. The knife breaks if you try to cut wood with it because it cannot withstand the cutting force. If you try to cut a tomato with an axe, the tomato gets squashed instead of being cut. Cutting edge geometry is as important on the shop floor as it is in the kitchen. The logic of selecting the cutting edge tool is the same. Inserts have different cutting edge geometries for different materials like steel, stainless steel, cast iron, and aluminum. There are also different geometries for different applications: roughing, medium machining, and finishing. This picture shows the edge geometry for various applications. You can see that the edge for roughing is blunt with a large cross-sectional area. This enables it to withstand the heavy cutting forces involved in roughing. This is like the axe cutting wood. Medium machining involves a smaller depth of cut and feed rate and smaller cutting forces. The insert for medium machining, the one in the middle, therefore has a smaller land and is sharper. In roughing and medium machining, the cutting forces also cause distortion and bending of the part. The dimensional accuracy is poor because of this, but we are not bothered about accuracy in these operations. The aim is to remove material at a high rate. In finishing, the cutting forces are low because the depth of cut and feed rate are low. The cutting edge in this case, therefore, is sharp with zero land. The sharp edge also results in low distortion and bending of the part, which is required for getting close tolerances. This is like the kitchen knife for cutting a tomato.